Alright, notes part 2. Here we are with solving trig equations. So, first example says, solve the given equation and list 6 specific solutions. So with a lot of these, because the sine, cosine, tangent functions are periodic, meaning they kind of keep going, there will be an infinite number of solutions. This is asking for 6 specific ones. Our equation is that sine theta equals negative root 3 over 2. So start by drawing or thinking of a unit circle, and we know that sine is the y-coordinate. So negative root 3 over 2, we know this is the long side, the short side of the triangle. If you're struggling with the unit circle, you could look back at some of those unit circle notes videos. So this angle ends up being 4 pi over 3, and this angle ends up being 5 pi over 3. So we could have this angle 4 pi over 3, and we could keep going another 2 pi, and we could keep going another 2 pi. Same with the 5 pi over 3. We can also, because it didn't specify, sometimes the questions will say something like this. Theta is between 0 and 2 pi, meaning it has to be some positive value that has started and gone around. But because it didn't, negative angles are okay. So this angle right here, if we were talking about negative angles, would be negative pi over 3. And get some orange here. This angle would be negative 2 pi over 3. So both of those are acceptable. And you could also say negative pi over 3 minus 2 pi k, etc. So anyway, when it comes to choosing 6, we have an infinite number from which we are choosing. So what did I say? 4 pi over 3 and 5 pi over 3, and then I think I went once more around, so here's 4 pi over 3, and then added 2 pi to that. So this right here is just common denominator stuff. We'll zoom in for us. So 4 pi over 3, so 2 turns into 6 over 3, and we have 10/3 pi as our next angle around from 4 pi over 3. And then same thing with 5 pi over 3, added 2 pi and came up with 11 pi over 3. So those are these answers right here. And then I threw in those negatives. Hey, this doesn't look right. Just testing us. Let's see. So the good thing I'm paying attention. All right, so negative pi over 3. Who wrote this? And negative 2 pi over 3. Just like we said here and here. Okay, so negative and positive angles, infinite number of solutions. It was asking for 6. There they are. Okay, see if we can find some typos down here. So find all solutions of all solutions. So we're going to have that 2 pi k or pi k thing of the given equation. And we're going to do some algebra to isolate, to get sine of theta by itself first. So add 3, divide by 4, take the square root, and then we know that square root of 4 is 2. So that's how we ended up with this. And notice how when we took the square root, we ended up with a plus or minus. So this throws a whole bunch of possibilities into the game. Sine is the y-coordinate. So up here, this is a positive root 3 over 2. And we could be drawing our triangles like this. And down here, this is a negative root 3 over 2. So all of these angles satisfy that equation, meaning you could type this into the calculator or Desmos and it would tell you 0. And same with this, same with this, same with this. Okay. But it says all solutions, so theoretically, technically, we have this plus 2 pi k. We have this plus, 2 pi, sorry, this is a new stylus, and I think I like it when it writes, and 2 pi k and 2 plus 2 pi k, because this angle we can go all the way around and we end up in the same place. Okay, so we would have 4 different things, and I think I wrote those all. Let's see what we have here. Pi over 3 plus 2 pi k, 2 pi over 3 plus 2 pi k, it's like a tongue twister, 4 pi over 3 plus 2 pi k, and 5 pi over 3 plus 2 pi k. Now, we could write that a little more simply. Let's use, just to totally mess up this picture, some bigger ink. Okay, so this angle right here, so we're at pi over 3. If we just went pi, we'd end up here. And if we went another pi, we'd end up here. And another pi, we'd end up here. And another pi, we'd end up here. And so on 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 and so on. So we could say this, pi over 3 plus pi k. So don't fall into the thinking that, oh, this is only for tangent and this is always for sine or cosine. We could, given these and given these, we could write these two solutions as this. So that is simpler than writing, where was it, this guy and this guy. And then I'll get a different color. So this and this can be written as this, which is the same as this and this at the same time. So this covers both bases, for lack of a better expression. So anyway, that's simpler and is correct. This is just more ink, or digital ink, or whatever, but both are correct. They show all possible solutions. All right, solve the equation. So in the last little bit, we had an example where we factored. So this is similar, except it's already factored. So we have something times something equals 0. We know that either this has to equal 0 or this has to equal 0. So it's like the factoring's already been done, and we take it from there. So if I set this equal to 0, I'm going to have a little algebra to deal with. No problem. So add 4, take the square root, don't forget the plus or minus. I want a little highlighter here. Where's that? Here we go. Alright, don't forget the plus or minus. And tangent of theta equals plus or minus 2. Okay, so this is weird because this is not something that we're used to in the unit circle. So let's take a look at what we're talking about here. What we're talking about here is, over here I have the tangent, right? And root 3 over 3, and 1, and root 3, and then 2 would be, so I have this written here in red. Let's touch that up a bit. So right here we have plus 2. So this angle would be a little bit greater than the angle that gives us root 3. Root 3 is 1.7, 1.71 something or other. So we don't know exactly how many degrees or radians this is. So I know this is a little weird. We're actually using the calculator, and here we've been learning all this stuff so that we could free ourselves of the calculator. But this is what Desmos tells us. So if you were to do inverse tangent of 2, it's going to tell you this in radians or this in degrees. And so based on our picture here, you know, if this is 60 degrees, that's pi over 3. So it does make sense that that's a little more, so 63.4. And this are the same angle. All right, that's just radians, that's just degrees. So we have this plus pi plus pi plus pi plus pi plus pi plus pi. And all the answers in the book are in radians, I think, so I thought I would write it in radians. But here's degrees, so you have a reference point. And then this angle down here, which would be for the negative 2, I did 2 pi minus this many radians. So 2 pi minus 1.07, just like you would do 360 minus 60 to get 300 degrees, and it's going to be something really close to 300 degrees, 5.18 radians. So the question didn't specify, it just said solve the given, just said solve the given equation. But if that's all it says, let's assume it means all solutions. So we have to put that plus 2 pi k or whatever it is afterwards. So here we are, right here. Oh look, I made that mistake again. Oops, who's in charge here? So 1.1 radians plus pi k and 5.18 plus pi k radians. Okay, so that takes care of this. Hope we're not getting seasick. That takes care of that. We solved it. We got 2 different solutions and then all the variations. Next up, we got this guy. So if that is equal to 0, 2 cos theta plus 1, we have this over here. We're going to do a little algebra, so subtract 1 from both sides, and then divide both sides by 2, and we end up with this. So this looks like something that is on the unit circle, and we are familiar with this. So cosine is an x-coordinate, negative 1/2 is here, so we have these two angles. We got this 2 pi over 3 and 4 pi over 3. And because we're assuming it means all possible solutions, we have this, the 2 pi over 3, plus 2 pi, plus 2 pi, plus 2 pi, etc. And over here we have 4 pi over 3, and plus 2 pi, and plus 2 pi, and plus 2 pi, and plus 2 pi, etc. So, what was that? Yes, it was this. 2 pi over 3 plus 2 pi k for that guy, and then down here, 4 pi over 3 plus 2 pi k. So, 4 different answers for that equation, and each of these has an infinite number of variations, but notice how these are all in radians. I know it's tricky. People tend to get confused. They think radians means it has to have a pi, and they see this and they're like, I have no idea what that is. This is still radian measure. Remember, think about a circle, the unit circle, and think all the way around, you know, is 6.28 radians. So 1.1, it's about like that. And we did go through the thing where 1 radian is about 60 degrees. Okay, so if that's not messy enough, let's see if we can mess up this one. Last example here, home stretch. Solve the given equation. So we have this, looks like a factor thing. I think I wrote this somewhere, but so it'd be like that, which would factor to this. And if you see this, and getting to this is just way challenging, you should probably do this and do this intermediate step. So this would factor to x minus 2 and x plus 1. So that's where I got this sine theta minus 2 and sine theta plus 1. And if you're seeing the question and you're seeing this and you're like, hey, I don't believe him, he's lying to me, go ahead and FOIL and prove to yourself that we are correct. All right, firsts, outers, inners, and last, and you'll end up with this. Promise. Okay, so this tells us two things. It tells us this equals 0, or this equals 0. So we set those two up. We'll deal with them separately. So sine theta minus 2 equals 0. We're going to do a little algebra, add 2 to both sides. Sine theta equals 2. No way. Remember, sine theta or cos theta, they're always between 1 and negative 1. It doesn't fit on the unit circle. If we're thinking about the unit circle sine theta 2, be way up there, and it's got to be somewhere on the circle. Okay. Next up, we had this guy. Sine theta plus 1 equals 0, so let's hone in on that. Sine theta plus 1 equals 0. I'm going to subtract 1 from both sides. This definitely looks like something I know from the unit circle, and that is this angle right here. Negative 1 is the y-coordinate, and that angle is the 3 pi over 2. Okay, so if we're looking for all solutions, I think we're going to say this, 3 pi over 2 plus 2 pi k, because it could go around and end up in the same spot. All right, I think that's it. Your learning pleasure is over. Thanks for listening, and we will solve some more trig equations in class.